Okay, the cerebellum is important for kind of sort of like the basal ganglia. It helps fine tune and coordinate movements, but it's also important as it is this like central point of integration for balance. So you can get severe vertigo and ataxia if it's defective. So it's going to integrate kind of these three inputs: things from the vestibular system, things from the proprioceptive system, and things from the visual system to help keep your posture intact. So I kind of went on a crazy photo shoot. So we're gonna fly through all of these dumb photos that I took, but maybe it'll help. Just for me, it was always confusing just to understand the geography of everything. But cerebellum means little brain, and it kind of is like a little brain, just south of the tentorium cerebelli that we see right here. So it's infratentorial, and there it is. So it's bunch. It's got a posterior lobe. We'll get into it. So here's the posterior lobe right here. Mental snapshot. Here's the vermis in the midline. Mental snapshot. Here are the tonsils. The tonsils here. This is what can herniate if you have a Chiari type 1. And if you have Chiari type 2, which is more severe, you might also have the vermis shown here also herniate. In other words, squeeze through this foramen magnum that we're looking at. And we see these longitudinal striations, and we know that is the medulla. All right, so the anterior lobe now, again, I guess it's peaking a little bit above the tentorial layer, but mostly it is infratentorial. So we just remove this, kaboom. We're now looking at the anterior lobe, which we haven't seen yet. And again, here you have the vermis. Here you're going to have the tonsils. Here you're going to have the posterior lobe. And now there's this nice division, this horizontal fissure here and this primary fissure to just demarcate different landmarks. Again, we're looking at the vermis. Excuse all these dumb photos. Looking at the anterior lobe. We're looking at the posterior lobe. Notice how big the posterior lobe is compared to the anterior lobe. And the flocculonodular lobe, which is hard to actually see, but it plays a really important role in balance and integration of visual and vestibular inputs to help keep you from falling over. So it's going to be important for things like the Romberg test. So dumb little video, but we have three different peduncles which are going to attach the brainstem to the cerebellum. The inferior and the middle one have to do with afferent inputs. So information is coming in. You can imagine coming in from the eyes, coming in from the vestibular system, coming in from proprioceptive, from the dorsal column, medial limniscus. And then the efferent is going to be from the superior part, which goes through the midbrain and up to the cortex and says, hey, let's try to coordinate our movement in an XYZ manner. So that's the inferior. Oh, gosh. Did it even work? Nah, I don't care. All right, that's inferior, that's middle, and that's superior. You get the idea. All right, so again, proprioception, vestibular sight is coming in from the bottom, in from the middle. It's getting processed, and then it goes out through the superior cerebellar peduncle. And here's another dumb video. I think I was just too proud that I understood it. So we're highlighting right now the superior cerebellar peduncle hidden right there. And let's see what happens. Okay, then there's the middle one. There's the vermis in the midline. There's the anterior lobe. And then there's the posterior lobe. And there's the flocculonodular lobe. Again, posterior, vermis, tonsils, medulla. We can see all of these nice longitudinal striations. The pons, the big fat pons. Sounds like a nickname for your, if you got a big pot belly, you got your pons. And it's kind of sticking out like that. And then our pituitary with the infundibular stalk. Arbor vitae, because if you look at this from a sagittal slice, this looks kind of like a tree here a little bit, right? And of course, this is our third ventricle. This is our fourth ventricle, interventricular foramen of Monroe. We have the lateral apertures and the medial apertures of Magnapi and Lushinka or whatever. So I don't understand this as well as I probably should have. So take go on with a grain of salt. But I think more or less this is what's happening. Maybe getting a detail wrong, and definitely leaving out a few details. But we have these inputs coming in. So they come in. They rest at this little nucleus right here. We have the dentate, the emboliform, and others, which we'll get to. And so they're going to come here, and then they're going to branch out. And they're going to get processed. That processing goes back to the nucleus, maybe gets processed a little bit more, goes out, and then that becomes the efferent to the brain. That's my dumb understanding. There's definitely a lot more to it with Purkinje fibers and Mossy fibers and whatnot. There's another little simplification of it. All right, so here are the ones we were talking about. We have the dentate, the emboliform, the fastigial, and the globose nucleus. And so people remember this is don't eat greasy foods. That's moving from the lateral to the medial. And the eat greasy sometimes are called the interposed nuclei, the ones in the middle. So we've mentioned this as the anterior, as the posterior, the big one, and the flocculonodular lobe. We kind of have a vermis in the midline and the tonsils in the midline of the posterior section. But another maybe more common way is to think of this as the spinocerebellum, which is really just the vermis for the most part, the vestibulocerebellum, which is really just the flocculonodular lobe, and the cerebrocerebellum, which is really just the lateral parts of the cerebellum. And that would include here what we're seeing with the posterior lobe, the large one, and a little bit the anterior lobe well as here. So notice the spinocerebellum is going to pick up a little bit of the, the posterior and the cerebellum as well. But this is probably a better physiological way of thinking through it. So the spinocerebellum is for properly executing coordinated movement. So this is something that's actively occurring, right? Like I'm walking down the street, and my cerebellum is helping input each of my steps so that I don't look silly and trip. It's using largely proprioceptive information from the dorsal column medial lemniscus and the spinocerebellar tract to achieve this. So that is the central midline. And so that would be kind of like that would be the interposed nucleus, but especially the fastigial nucleus. Don't eat greasy foods. Eat in greasy or the interposed. Then we have the lateral parts. Again, this is posterior and anterior. The lateral parts for planning coordinated movements. So if I want to, do a wicked serve in tennis, the cerebrocerebellum here, the lateral parts of the cerebellum are going to help me execute this function as well as I can, which is not that well. And then the vestibulocerebellum is kind of in the name. Vestibular has to do with balance, right, from the ears. And this is just really the flocculonodular lobe. And this is going to be mostly the this is really just coordination and balance. So a little bit of a link here with this as well. And this is going to receive balance information from the semicircular canals, the vestibular nuclei, and the superior colliculi and the medial visual system, basically, right? And we said that there are 1, 2, 3 things for balance, and they are going to be the proprioception. We have that over here, and then we have the vision and the vestibular system over here.